Welcome back, audience. We were briefly interrupted in our discussion of uh, the first scenario that we were going to be talking about carbon nanotubes. And in that discussion, we wanted to basically bring about any hazards and controls that you can apply to the workplace. Um, so I'm going to pass it on to Mr. Abdul Rahman again to start that discussion. Go ahead.
Yeah, yeah. So where we left off at, we were discussing the scenario, the hypothetical scenario of, and it's not only hypothetical. There are industries, even though they are not as widespread um, as established industries, but they exist, where the scenario is you're designing a composite, you're manufacturing a composite that has carbon nanotubes um, in lightweight vehicle parts. And a potential hazard is when they're cutting or grinding the finished composite, creating dust.
Yeah.
So, how do we apply the principles we talked about earlier in this scenario? Okay, so my answer would be this is a high concern scenario. Okay. So the carbon nanotubes, I think, as we alluded to earlier, the toxicology is similar to asbestos because of their shape. They're long, fibrous, um, and have very high aspect ratios, as you see in this diagram. Carbon nanotube is essentially imagine a sheet of graphene, and then you roll into a cylinder. That's basically a single-walled carbon nanotube. And then there's multi-walled carbon nanotubes where you have several layers of graphene rolled into concentric cylinders. Um, and I know in the science in the discussion there are some difference in the toxicology if it's single-walled versus multi-walled, but for our intended purposes we can just treat it as a high risk scenario, and it behaves like asbestos. So it
Right.
may, yeah, pose a lot of, so of course, as we all know, asbestos causes lung issues, pulmonary inflammation, fibrosis, and when you inhale carbon nanotubes, it can, bypass the lungs' defense mechanisms, right? But they call the alveolar macrophages, those cells that are supposed to engulf foreign particles.
Yeah.
They become frustrated and they're unable to handle uh, foreign fibrous,
So the lungs'
material.
immune defense mechanism can be bypassed because of the
Yeah.
size of these molecules. Could
The
you
size and
also
the shape,
size and the shape
long
exactly,
fibrous shape. Yeah.
which is very analogous to asbestos?
Yeah, exactly.
Okay. Could you also comment on the polymer graphene itself? I know because carbon nanotubes are so analogous to asbestos, which are known carcinogens.
Yeah.
We are applying that same concept to graphene and carbon nanotubes and these polymers as being equally carcinogenic. Now, when it comes to workplaces, we deal with um, the application of carbon nanotubes as we spoke about earlier in the earlier scenario. Um, so, how can we control this hazard? How can we control people being exposed to it? What kind of options do we have from an engineering control perspective?
That's a good question. Just a small, I would say, correction, or so I wouldn't classify graphene as a polymer. It's you may think of like because polymers are carbon, they have carbon chains, but
Yeah.
this is would be more of a crystalline, carbon lattice. It's less more of an inorganic kind of substance,
Okay.
but not a polymer, just small correction. But yeah, there is some concerns about the toxicology of graphene, especially if inhaled and because of the size. And yeah, we can discuss about that. Um, how can we prevent, how can we mitigate the risk, right? So, what kind of controls? So there is essentially, essentially what you need to do, you need to like, I would say there's three levels of controls. So there's the first, I strongly believe in the saying that prevention is better than cure.
Yeah.
There's the from the source itself. So in the scenario we gave where we're cutting, this composite material, and it has, some nanomaterials inside that can cause, for example, carbon nanotubes.
Yeah.
In this case, you would try to, from the actual source itself, you would try to, have some sort of suction, what we call LEVs, right? Those suction exhaust tools.
Yeah.
The ventilators are placed very close to where you're cutting. That way, even before it has a chance to reach your face or your lungs, it's already being sucked, right? But of course, obviously, this alone is not sufficient. You cannot expect 100% suction from that kind of tool. So then there'll be a second layer of control, which is there's one easy way actually, which is, well, let's think about the way we're cutting it. Do we have to use a dry cutting method? Can we use a wet machining? Right? There's machining tools that use water,
Yeah.
and the benefit of that is that the uh, any waste material, instead of being airborne into the as a dust, it just gets collected and caught as a slurry in water.
Yeah.
And that way basically it prevents it becoming airborne.
Airborne. Yeah.
That's the second layer, what they would call a process change.
Hmm.
And then also I would say filtration. So in addition to just your localized, you know, exhaust, you have the filtration in your entire building or room, right? The HEPA filters.
Yeah.
Of course, if you have your local exhaust ventilator, but it's not connected to a proper filtration system, then all you're doing is you're actually recirculating those carbon nanotubes back into the air, right? So it
Right.
has to be connected to a appropriate filtration system. And
Yeah.
of
Probably on
course,
the ceiling, you can apply that HEPA filter. So there's
yeah,
an extraction method as well there, right?
yeah, and of course, after all that, then you also add the final additional measure, which is their PPE, right? Your
Yeah.
respirator that can handle that kind of size. Yeah,
Okay, that's perfect. You also mentioned about housekeeping, which falls under administrative controls as one of the controls in the hierarchy of controls that, as a safety professional, we typically talk about.
yeah.
This bridges the gap between the machine and the worker. So, what would you mention about what can be done to improve that process? Can there be any protocols applied or any documentation that can be created for that administrative control purpose?
Yeah, so I would go to like SOPs, standard operating procedures. So workers need to be trained. They need to know, okay, they need to be trained on how to prevent these hazards from, affecting them, even if you can't see it, but it's an invisible hazard. It can
Right.
still penetrate the lungs, that kind of stuff.
Okay. And the last line of defense, as you mentioned, the PPE. So do the standard P100 and N100 serve the purpose in this case?
No, no, it would definitely not. So,
Okay.
um, I would say so. I mentioned respirators,
Yeah,
but
so these are the filters that are applying to the respirators, the P100s and the N100s.
oh, I see. Yes, yes, yes. Oh, of course. Yes, yes. Yeah. Then they would work. They would actually work very well. Even maybe counterintuitive.
Yeah.
So you may think that the nanoparticles might slip through,
Yeah.
but
It could
because of
flip.
their erratic kind of diffusion behavior, they end up hitting the filter fibers and sticking there.
Okay.
So it actually works.
Perfect. Awesome. So you have guided us through
Just
some excellent points.
one very, very important
Okay, go ahead.
caveat, and I had to do that myself when I was in a weld fume environment, is that I was required to shave off my beard
Oh,
uh,
yes, yes,
and to make
absolutely.
sure there's a seal.
Hmm.
Because if you're all these big gaps that your hair creates between your respirator and your skin,
Yeah,
uh, it will just go right through. So I had to I had to shave off that beard, especially when they were doing the when I had to wear it,
right.
um, and especially when they were doing fitting, they do some tests to make sure that it actually is a seal, and you won't even
Yes.
pass that test unless you clean shaven.
Yeah, so there are quantitative testing methods to ensure that there's a proper seal and
If the company that
yeah.
doing the service of providing the PPE are doing the job correctly, they would when they're fitting it on you, they have to make sure that they mark that you have passed the test and you're
Yes.
fitted properly uh, before and that before you can be considered that you have appropriate PPE. Appropriate PPE, yeah, sorry.
Awesome.
Personal protective equipment, right?
Yeah, personal protective equipment. That's a very key word. I think sometimes the workers in the workforce, this is the last line of defense that they usually manifest within the workplace as the first line of defense due to lack of all the knowledge that we've discussed. Some of the engineering control methods, the ventilation controls, the local exhaust ventilations that you've earlier mentioned, the HEPA filters, the applications of the combined effort, I think does the job rather than just the PPE by itself. So you brought some excellent points, and I think similar to silica hazards, exposure control planning, fit testing, worker training becomes extremely important. As you mentioned, fit testing is also critical. So this has been an incredibly useful insight so far, this discussion. It's clear that employers need to involve occupational health and safety professionals and engineers alike earlier in the process when planning to work with these nanomaterials. The landscape of nanotech safety is moving faster than ever at Arman and Associates. We don't wait for the penalties or workplace injury claims. We help employers protect workers now. We offer services in the field of health and safety consulting, in the field of construction, engineering, manufacturing, transportation, healthcare, and more. One of our biggest advantages is our network of associates that help bring these critical subject matter expertise to every job we take on. Um, Mr. Abdulrahman, thank you for your expertise. Thank you for your guidance today and this fruitful discussion. And I thank the audience as well.
Thank you. Thank you so much. I really enjoyed this. Appreciate it. Thank you for having me.
Awesome. And for the audience, thank you for watching and stay safe.
All right.
Until
Enjoy
next
your
time.
evening. Okay.